The role of maritime theater of operations has significantly increased, but to create a traditional fleet of aircraft carriers, cruisers, and destroyers capable of competing on an even level with the strongest fleet today, the US Navy, is extremely complicated. For this reason, the maritime powers are looking for asymmetrical approaches in the construction of the fleet of the future. An interesting asymmetrical solution is presented by the Ekranoplan. Ekranoplan is a high-speed transport vehicle flying within the limits of the aerodynamic envelope at a relatively low altitude, a few meters above water, ground, snow, or ice. The Ekranoplan is much smaller than an aeroplane with comparable mass and wing area. According to the International Maritime Organization (IMO) classification, it is considered a seagoing vessel. A ground effect vehicle, GEV, is a vehicle that is designed to attain sustained flight over a level surface, usually over the sea, by making use of ground effect, the aerodynamic interaction between the wings and the surface. Among the best known are the Soviet Ekranoplans, but names like Wing and Ground Effect, WIG, Flarecraft, Sea Skimmer, or Wing and Surface Effect Ship, WISE, are also used. Experts consider it entirely possible within the next 5 to 10 years we'll see the appearance of heavy military ships from 500 to 5,000 tons of displacement. The Ekranoplan Lun, built in the USSR in 1987, has a displacement of 380 tons. For comparison purposes, the maximum takeoff weight of the biggest aircraft's AN-225 is 640 tons, and the Airbus A380 is 560 tons. Lun is a Project 903 Soviet missile launching Ekranoplan according to NATO codification Utka or Duck. The Project 903 Ekranoplan was designed for combat against surface ships using missile strikes under conditions of friendly air superiority. The main targets of the missile carrier are aircraft carriers. The Ekranoplan Lun, thanks to its high speed and radar stealth, can approach aircraft carriers to within effective missile range. Today, the Ekranoplans are produced with a displacement of up to 3,000 tons, though craft between 1,500 to 2,000 tons are typical, and both the engineering and technological issues have been resolved. Such displacement will allow the installation of various weapons and hardening of the airframe, including by armoring important components. It will also allow the installation of a power plant, giving the Ekranoplan cruising speeds of 400 km per hour and a maximum speed of 500 km per hour, with fuel reserves ensuring range of 5,000 to 7,000 miles. Current airplanes weighing 200 to 300 tons can fly without refueling 10,000 to 12,000 kilometers. The main reason for the interest in the Ekranoplan is its incomparably higher speed than that of naval ships. This provides an opportunity for operational and tactical group maneuvers in terms of approaching similar levels of aircraft. Thus, the Ekranoplans are invulnerable to current anti-ship missiles, which can only engage slow-moving targets. They may be engaged by air-to-air missiles, though the Ekranoplan's ability to alight on the water limits their effectiveness. When comparing with traditional aircraft, the advantages of the Ekranoplans in the cruise control mode at extremely low altitudes over the entire route and with the ability to alight on the water with minimal fuel usage allows to significantly increase the on-station time and the weapons load. An important advantage is the prolonged endurance, potentially reaching several days. The weaknesses of the Ekranoplans include the limits of weaponry that can be used, be it naval or aircraft. The main use of the Ekranoplan is combating surface ship groups such as aircraft carrier groups. The high-speed ships deprive the enemy of time for distances greater than 500 kilometers to detect the Ekranoplans traveling directly over water and attack them. Their significant size will allow them to carry anti-ship weapons sufficient to inflict enough damage to the aircraft carrier group by 4 or 5 Ekranoplans as well as SAMs to counter enemy fighters. The technical aspects of such Ekranoplans will probably be of 1,500 to 1,800 tons displacement with speeds of up to 500 kilometers per hour for distances of 5,000 to 6,000 miles. Main weapon systems of 12 to 16 anti-ship missiles with an effective range of up to 300 kilometers, SAMs with range of 120 to 160 kilometers, 1 or 2 30mm guns for close-range fights, 4 small drones for surveillance. This machine is capable of quickly reaching the launch point for anti-ship missiles, launch, then swiftly evade from fire. For the destruction of enemy surface ships in enclosed marine theater, Ekranoplans can be used against groups of ships of relatively small displacement, primarily in zones of powerful anti-aircraft and anti-ship defenses. There exist designs with displacement between 100 and 150 tons with speeds of 450 to 500 kilometers per hour and a range of 500 miles while carrying 4 to 8 anti-ship missiles. The capabilities of the Ekranoplan moving at high speed, overcoming enemy defenses, including in areas unreachable by other classes of ships and boats, makes it attractive for amphibious operations. It is these qualities that are important for the first wave of landing troops, which in cases of strong anti-landing enemy fire solves the problem of capturing the foothold. As the condition of conducting amphibious operations is the conquest of the air and sea superiority in the landing area, assault Ekranoplans do not require heavy armament. The need to lay down suppressive fire on the beaches can be satisfied by a multiple launch rocket system, MLRS. Given the likely volume of fire missions, it is best to have on board 12 220mm rockets or 40 122mm rockets. With this equipment, the possible number of troops on board the Ekranoplan of 200 to 300 tons of displacement can be estimated at one company of infantry with standard weapons and equipment.
Russian media reported in recent weeks two new developments concerning the PAK-FA, or the Future Aviation System Frontal Aviation. In addition to the news of the 6th T-50 prototype taken to the air and 5 additional ones being in advanced stages of construction, the Russian media reported that the T-50 would enter service with the Russian Aerospace Forces already in 2017, in other words, in little more than a year. The aircraft series production would commence the same year. It is quite a milestone for this highly ambitious aircraft program that began comparatively recently in 2001 when the Ministry of Defense issued its final list of specifications for the aircraft, though preliminary research on the prospective successors to the Su-27 and MiG-31 fighters was launched already in the 1980s. These specifications included super maneuverability comparable to, if not better than, displayed by the Su-27, super cruise, or the ability to travel at supersonic speeds without the use of afterburner, multi-role capabilities including the ability to engage air, land, and naval targets with a wide spectrum of long-range guided munitions, advanced electronic suite in the form of an active phase array radar with near 360-degree coverage thanks to the side and aft-looking aerials and so-called glass cockpit that allows the pilot to avoid being overwhelmed by information, and of course stealth or low observability in both active and passive sense of the word, with the T-50 being able to engage targets without the use of its own onboard radar. Contrary to much negative propaganda emanating from Sukhoi's Western competitors, the T-50 project development turned out to be smoother than many anticipated, largely thanks to the parallel evolution of the Su-27 family of aircraft, which was used to test and improve new technologies before incorporating them into the T-50. In that respect, it may well be that Sukhoi has taken over from Lockheed Martin as the world's foremost fighter aircraft design bureau, as the long list of developmental problems experienced by both the F-22 and F-35 programs suggests that its design culture was disrupted by the multiple defense mergers of the 1990s. Which means that, whereas the T-50 stands on the shoulders of the Su-27 family, the F-35 is being designed as if it were the first product of a newly constituted design bureau. The planned 2017 service entry date will only be another milestone in the life of the T-50 program, with many to follow. The initial frontline squadron aircraft will most likely be narrowly capable air combat machines, just as the initial Su-27 fighters were. It will simply be the spear tip of a new era of Russian military aviation. However, just as the Su-27 spawned the Su-30, 33, 34 and 35, which now collectively comprise the backbone of the Russian Aerospace Forces, the T-50 will similarly acquire new capabilities and serve as the springboard for spin-off models, so that in a few decades' time the T-50 will be the backbone of the Aerospace Forces, likely supplemented by smaller MiG fighters, combat drones, and possibly even the 6th generation fighter. The only unknown aspect of the program is its service designation, for the T-50 will surely acquire a SU designation upon being accepted into service. Fully implementing the T-50's capabilities will also require the development of a new range of munitions capable of taking advantage of the design's internal weapons bays. Even though the T-50 can carry older ordnance under wing, it is also evident that a range of weapons is under development. An example of such munitions is the KH-59 Mk2, a derivative of the KH-59 missile family that was demonstrated at the MAX 2015. This new modification, which combines stealth, 300 km range, 300 kg warhead, and a variety of guidance systems enabling it to engage both stationary and mobile land and sea targets, is indicative of the nature of the T-50's future arsenal. While no single weapon system is in and of itself decisive, the T-50's imminent service entry undermines one of the crucial NATO assumptions, namely that of air superiority. Even the initial small fleet of T-50s backed up by the Su-35 and Su-30 fighters would be enough to deprive NATO's land forces of the ability to operate without worrying about attack from the air. Given how unused and unprepared NATO is to operate in the face of opposing air power, the T-50 is an important component of Russia's conventional deterrence posture.
The Armata tank has become a real challenge for NATO tank builders. Design officers of Western countries were discouraged by the tank's passing into service, which has the most advanced features in terms of mobility, protection, and firepower. That is why tank builders have had to adjust their current projects on future tanks and prepare them for a possible confrontation with the Armata on the battlefield. But are the efforts being made to catch up to the Russian engineers successful? At the Euro-Satori exhibition, which was held in June in France, German weapons company Rheinmetall presented a promising sample of a 130mm gun, L-51, which is aimed at combating modern armored vehicles, including Russian main battle tanks MBT T-14 and the Armata. The latest modifications to the T-90 were also presented. Manufacturers are affirming that the gun will be between 10% and 50% more efficient than the previous model of the 120mm gun, the L-55, which is widely used in the army. However, the manufacturer has not reported on the method of estimation for the effectiveness of the gun. Despite the increase in the firepower of the gun, its weight remains almost the same. The shutter with a vertical locking mechanism weighs about 3 tons and the trunk has a weight of 1,400 kilograms. This result is achieved through the use of high-tech materials and optimal design that allows for the new gun to be used on existing tanks of the latest modification, such as the German Leopard 2A7. This means that the weapon can be distributed widely. It can also be installed on the projecting German-French tank, the MGCS, which is anticipated to be placed into service after 2030. To increase the armor penetration for the gun, new, longer and heavier projectiles were developed. Armor-piercing fin-stabilized discarding sabot APF SDS, as were separable trays and high-explosive air-bursting munitions HEABM. Despite the manufacturer's declaration of the significant increase in the firepower of the guns, experts have expressed doubts. The sample that was presented is designed for manual loading, and experts have confirmed that the rapidity of fire cannot exceed more than 6 to 8 rounds per minute. The T-14 has an auto-loader which provides for the rapidity of fire of about 10 to 12 rounds per minute. Regarding the increased efficiency of the gun's shot, as claimed by Rheinmetall, it must be noted that the round's DM63 for the previous gun model, the RH-120 L-55, which is installed on the tank Leopard 2, has a penetration of up to 800mm of homogeneous armor. Therefore, an efficiency of 10% in the L-51 model yields 880mm. In comparison, Armata's 125mm gun, the 2A82-1M, provides armor penetration of between 850mm and 1000mm. The 152mm gun, the 2A83, which has been tested in the 90s and into the century, will be installed on Russian tanks in the future. Hit 1 at 24mm of homogeneous armor. It is known that field tests of the German guns were not carried out and that the gun has not been set on a real tank. Therefore, it is hardly possible that a 50% improvement in the performance of the German gun can be said to be achieved. The Russian tank crew is set in a separate capsule protected by a modern, multi-layer counter-heat protection effect armor.
In addition, a dynamic Armata Malashit protection system and the active protection system Afghanit provide protection against all existing anti-tank weapons. Finally, according to Armata's developers, the mounted machine gun, which obtains data from the Active Electronically Scanned Array (AESA) radar, is able to protect the tank by knocking the flight of anti-tank missiles and changing the trajectory of the rounds or damaging commutative jets. It appears doubtful whether the new German gun can defeat such a fortress at this stage, even with a possible 50% increase in its efficiency. Of course, much depends on the situation awareness systems used, the ammunition, fire correction systems, and electronic warfare. But it will take years or decades to develop such a combat complex and corresponding strategy of its application. It should be kept in mind that Russian engineers will continue to design more sophisticated armaments. Since it is possible to now assert that the Armata is currently the most powerful and protected main battle tank in the world, Rheinmetall's affirmations that the gun can defeat the T-14 are seen as a marketing ploy in an attempt to attract the attention of potential customers to the objective problem of the need to combat the modern Russian tank. The arms concern also raises the question of the expansion of financing for such developments. Clearly the Western, or at least the European tank building industry is behind the Russian industry. Nevertheless, the US military technologies could pose a significant threat to Armata, as demonstrated by the Future Combat Systems (FCS) and familiar doctrines. US military strategists are betting on the interaction of unmanned and mixed combat systems operating in 3 dimensions: ground, air, and space. According to this approach, the target should be defeated from the zone located beyond the line of sight of the enemy. For example, a promising lightly armored 20-ton tank, the XM-1202 Project FCM, equipped with a 120mm gun XM-360, was supposed to launch the mid-range munitions MIMKE or MIMCE to a distance of 12 kilometers and targeted with drones, Class 1 T-Hawk or 4-Fire Scout. It is therefore more likely that in the coming years we will see more Armata-orientated systems of weapons and even so-called Armata killers.